Okay, so we're going to go to 2.5 and we're going to be solving 15, 16 and ready for more. When you're solving systems of equations, right? Let's make this a tad bigger. Oh, where did you go? Okay, when you're solving systems of equations, there's really three methods. There's graphing, elimination, and substitution. My favorite is substitution because it works on every system. Graphing also works on every system except for you can't get accurate answers if the answers are like decimals or fractions. So substitution is kind of like my go-to method. Elimination also works except for if there's nothing to eliminate, then it doesn't work. Does that make sense? So here, what I'm going to do is I'm going to set these two equal to each other. And then I'm going to see what happens. Okay, so 10 to the x minus 50 equals to 25. Okay, so 10 to the x minus 50 equals to 25. Then now I'm going to use SADMAP to figure out which I should do first. SADMAP is PEMDAS backwards. It's the order of operation in reverse order, right? So the very first thing I say is, hey, do you have any subtraction or addition on the x side? And you're like, yeah, Ms. Johnson, it's right there. It's minus 50. Good. How do you undo subtract 50? And you're like, oh, well, you'd add 50. Very good. So I'm adding 50 to both sides. And I get 75 equals to 10 to the x. Now that 10 to the x is by itself, I can almost like drop this. If you're wondering where x is, it's in the exponent. So I'm just going to proceed this way, right? And then there are several ways that you can solve this, right? One way to do this is by graphing. Another way to do this is by guess and check. Another way to do this is to rewrite this in log form. And another way to do this is take the log of both sides. So my preferred method is to take the log of both sides. So I'm going to just show you that really quick. So I'm just going to put log, and I'm going to use whatever base the x is in as my base. So because it's base 10, I don't have to write a 10 here because that's the common log. So I'm going to squeeze that little log in there and put my equal sign in there. So then if you know how to do this, this will, this whole thing simplifies to just x because they undid each other, right? Just like this minus 50 plus 50 undid each other and it left 10x. This log base 10 of 10 undoes each other and I'm just left with x. So my answer, my exact answer is log of 75, log of 75. And so I'm pretty much done, but I want an approximate answer so I can check my answer. So of course I go to my best friend Desmos. It's not really my best friend, but you know. So I'm going to plug in log of 75 and see what I get. So I get this answer 1.875. 1. So about 1.8751. So I'm going to check my answer in two ways. I'm going to check it algebraically. I'm going to plug this number in to here to make sure that I get this answer is the same. So I'm going to go 10 to the 1.8751. And then I'm going to go minus 50. And see how this is 25 and this is 25? That means I did my answer correctly. That's what I was hoping for. The other way that you can check your answer, and this is actually the first method, is if I plug both of these in as functions to graph. So I'm going to erase that. I'm going to put x here, and it looks like a straight line. It's not. If I zoom out enough, it'll be you'll see the exponential. Okay, and the other one I want to plug in is y equals, and I'm going to have to put y equals 25. There you go. And it looks like you can't see anything, and I'm just going to make this big for just a second. It looks like you can't see anything, but you need to zoom out because it says y equals 25. So he's all the way up there. He's off screen. So I'm going to zoom out. Oh, there he is right there. So again, the most important part of this whole picture is where they intersect. And as I hover over here, it says 1.875 is my x. And that's exactly what we got right here. And that's exactly what we got right here. So therefore, I'm right. Yay. So when you're checking your answer using graphing, using the algebraic method, the important thing there is to check your answer. Always check your work, okay? Whether you're doing math or you're doing, you know, in the future, your job, check your work. Okay. Next one, I'm going to use the same exact thing. I'm going to plug in, I'm going to substitute x plus 5 in for y, and I get 10 to the negative x. And I'm still going to use SADMAP. I'm still going to use SADMAP. So here's my SADMAP. Okay. Very good. And then, so I'm going to look for, the very first thing I'm going to look for is there any subtraction or addition? And right there on the x side, and I'm like, wait. There's x's on two sides, Miss Johnson. Yeah. And so this is the confusing part. Hold on a second. I need to grab something. This is the confusing part because we do have x's on both sides. So, so for this one, I'm not even going to attempt to solve for it. I can explain to you how to do it. But if you did this, if you continue walking through here, right? If you continue walking through here, it's going to get a little confusing because I'm going to have a log inside the x and a log and an x outside the log, or an x inside the exponent and an x outside, which just by years of experience of solving these, they're going to be stuck in there. So I'm going to abandon this method right now, and I'm going to use graphing. Now, I wouldn't don't ever think like, oh, look, I made a mistake. Let me just throw all my work away. So technically, I didn't make the mistake. It's just, I know what's going to happen in the future as I walk through. Actually, let me show you what I mean. So I'm going to subtract 5 from both sides. And I get x is equal to 10 to the negative x minus 5. And then, so, but then it's like, okay, wait, should I take the log now, Miss Johnson? And it's like, okay, well, if you did take the log right now, right, then this guy right here would be kind of cleared, except for this guy. And then now you have a log, x inside of a log. So let me show you more. Okay, so then I say, no, let me not subtract 5. Let me take the log first of both sides. So then you take the log of this side and the log of this side, and you're like, cool, like I undid that. So now I have negative x is equal to log of x plus 5. And you're like, shoot, my x is stuck in a log. Okay. So I haven't taught you how to do this with that. So I'm going to run to my best friend, this guy. Okay. My graphing calculator. So x plus 5, that's what that looks like. And then I'm going to graph 10 to the negative x, 10 to the negative x, and I get that guy. And so here's what I get. I get this picture here. So again, the most important part is you looking for where they intersect. So as I hover over here, I get those two numbers. Now, the number that I'm interested in is the x number. So the x number is negative 0.64. So actually, that's what I'm going to be using. Negative. So x equals negative. Oops, you can't see what I'm doing. X equals, I don't know why I did that. X equals negative 0.64. And so that's my answer. And then I would tell Ms. Johnson, I did it by graphing. Okay. And that's pretty much it. So Ms. Johnson, why did you run to graphing again? Because I got stuck right here and I had x inside an exponent and an x outside. And so I tried taking the log of both sides, and then the x outside of the exponent I was good on, except for now I had a log of x plus 5, and that wasn't good. So that's why I went to graphing. All right, so ready for more. So it says solve the equation 2 to the x minus 1 equals to 30. So again, you could kind of see how you could plug this into your graphing calculator. This is one function, this is another. But it says use base 2 log to find an exact expression for the solution. So they want you to take the log base 2 of both sides, okay? So here, I'm going to write this over here, 2 to the x minus 1 equals to 30, and I'm going to leave some space so I can actually take the log of both sides. So I'm going to take the log of both sides. Sorry, I had to refresh my screen because it's kind of taking time. Oh man, there you go. It goes all the way over here. Where are you? Oh, there you are. Okay, so I left some space in here just so that you could see a little bit more of my log base 2 in there. So I'm going to take the log base 2 of both sides. And you know now that these two, log base 2 of 2, undo each other. So this is just left with my x minus 1. And this is left with log base 2 of 30. And log base 2 of 30 is some number that I don't know what it is yet, so don't worry about that. So then I'm going to add 1 to both sides to get x by itself. Oops, add 1. That one looks funny. Hold on. Okay, so x is equal to 1 plus log base 2 of 30. So this is called my exact solution. The reason why this is called my exact solution is because I didn't plug it into a calculator and there's no decimal approximations, right? When I plugged this into a calculator, actually I noticed that this needs to be a curly equal sign because, right, it's an approximation. See how I went from equal to approximately because I plugged it into the calculator. Even if you copy every single digit, it's still an approximation because the calculator is not going to tell you every digit because literally pi goes on forever. Calculators are limited, right? Okay, so this says solve the equation 2 to the x minus 1, and then it says use base 10 algorithm to find an approximate for the solution. For an approximate for the solution. So right here, I'm going to pause you guys and not worry about this one, this method 2, because we haven't talked a lot about this. And so I don't want to confuse you with this right here, right now. We will come back to this one so that you will be able to see it. Okay.